Okay, so all right. So in this lecture, we are going to talk about what is pH. All right. So let's begin. First of all, what does pH stand for? Power of hydrogen. Okay. In other words, pH is determination of the amount of hydrogen ions in a particular solution. Right. That's its very definition. So let's have a look at the two things that concern us. Things can either be acid or they can be alkaline or base. Okay, so what is an acid? A solution that has more H plus ions than OH minus ions. What is a base? A solution that has more OH minus ions than H plus ions. Okay, so let's have a look at some examples. For instance, having a look at this one for hydrochloric acid. We've got 2H plus ions, 2 Cl minus ions. You notice there's no OH minus ions. This is going to be an acid. Okay. All right. Let's have a look at magnesium hydroxide. Magnesium 2 plus. We've got 2 OH minus ions. Magnesium hydroxide. You notice there's no H plus ions. Okay. It's the OH minus ions that make this. It's the excess of OH minus ions that makes this a base. It's the excess of H plus ions that makes that an acid.
Yeah,
okay?
What happens if there's no hydrogen?
If there's no hydrogen, then that's a good question. Then it's not going to be an acid.
Yeah.
It can't be an acid. Okay? If there's no OH minus ions, it's not going to be a base either. Okay?
So it's just neutral?
It'll be neutral. Yes, exactly. All right. So let's have a look at pH in more detail. All right. All right. Okay. So from the last slide, you could see that pH, the power of hydrogen. On one side we've got acids, and on the other side we've got bases. Okay, and we've got a base. And you can see that so we're talking about H plus ions, OH minus ions, and if you notice H plus ions, OH minus ions becomes water. Okay, so let's have a look here. When we have, say, distilled water, all right? So distilled water over here. Distilled water. So in distilled water, the pH is 7. So the pH ranges between 0 and 14. And right here in the middle, the pH is 7. Why is it 7? Because the molarity, the concentration, that's the molarity, okay? Molarity. Remember molarity, what's molarity? Is the
1 mole in 1
yeah,
liter of water.
1 mole in 1 liter, okay? It's the number of moles in the volume, okay? Moles in volume, all right? Okay, and one molarity is 1 mole in 1 liter. Okay, so let's have a look at this. So we've got H plus concentration on this side. We've got OH minus concentration on that side. This is the base, this is the acid. So let's have a look. Water, distilled water, is at 7. So pH is 7. What does that mean? It means
It's neutral.
It's neutral. And why is it neutral? It's neutral because they are exactly the same amount of H plus ions as they are OH minus ions. They match. What is the concentration of H plus ions? It is 10 to the minus 7. Okay, so here, that's a very, very small amount. Okay, that's 1/10,000,000th of H plus ions. And have a look at how many OH minus ions there are. Again, very, very little, but the same. 1/10,000,000th. Okay, so because they are the same, then the solution is neutral. There aren't any more H plus ions than there are OH minus ions. Okay. All right. So if you look further, you can see that if we look at the pH going down from there, From 6, you can see that's 10 to the minus 6. So you can see what's happening is there's an increase in H plus ions. And this increases 10 to the minus 6, minus 4, down to minus 2, 10 to the 0, which is 1. And here we have molarity of 1. So 1 molar is pH of 0. That's the extent. So if we had a 2 molar solution, it would be out of this range. We could not measure the pH of a 2 molar solution. The highest we can ever measure is a 1 molar solution. Okay, beyond that, this pH range does not apply. It's a very small range. Okay. On the other side, let's have a look at this. Again, if the pH is 14, it's very, very highly alkaline. Okay, in fact, it's 1 molar. There's 1 mole of alkaline of OH minus ions in 1 litre up this way. Okay, right. As you go down, you can see that it's getting less and less. As the pH drops, the amount of OH minus ions drops. Have you looked down here at the bottom where it's 0? Look at this. This is 10 to the minus 14. That's 100 billion. Okay? All right? So 10 to the minus 14. Actually, it's more than that. There's a billion is 10 to the 9. So there's a trillion. It's 100 trillion, not 100 billion. Okay? All right? So it's a very, very small amount. It's so tiny. Right? It's incredibly small amount of OH minus ions if you had a pH of 0, because it is almost exclusively H plus ions. Okay, like I showed you before with the HCl, there's no OH minus ions at all in that. So let's say we had, this was HCl in a solution of water, okay? All right? There would be no OH minus ions. There'll be so few OH minus ions if the molarity was 1 molar, that it would be this many. Okay? You need to appreciate how small this amount is. It's incredibly small. It would be like 1 drop in a whole lake. Okay? It would be that small. It would be incredibly small. Look at this one over here. Okay? Again up here. If the pH was 14, there'd be practically no H plus ions, no acid ions in this at all. 10 to the minus 4, that's incredibly small. So if you had caustic soda, which is sodium hydroxide, and you had 1 molar of caustic soda, there would be absolutely no acid molecule ions in it at all. It would be completely caustic, completely alkaline. Okay, so that's basically what pH is. So if you go out and you want to buy something that's got a pH like that matches your body, then we're looking at about 7.2. So that's above here. So you can see it's just slightly alkaline. Okay, so drinking water just slightly alkaline. Okay, all right. We try to keep it slightly alkaline. Otherwise, if it was acidic, it would start rotting away the infrastructure, the water infrastructure. So we keep it a little bit alkaline. Okay? Where's your stomach acid? Your stomach acid is way down here. All right? Sort of right in here, in between 1 and 2. So it's quite acidic. Well, let's see. Soft drinks, around about 3.5. So you can see the difference between your stomach and that is 100 times. So the soft drink, your stomach is 100 times more, or even it could be as much as 1,000 times more stronger than the soft drink. So do you think the soft drink will have any effect on the acidity? I don't think so. No. Okay? All right, so no, the soft drink will not, by the time it gets into your stomach and it will be diluted in your stomach, it will make no difference at all. Okay? So yes, you can put a penny in a Coke bottle and watch it get all shiny. It'll do a lot more shinier than that if you put it in your stomach.
Yeah.
All right, so that's basically it. Other things, so milk sits around here in, between 7 and 8. And then there's other things like soaps. Soaps, and that would have higher alkalinity, so they could be 9, 10, 11 and so on. Soap that you wash yourself would be around about 8, 9. Okay, so some people like to wash with a low pH. You're wasting your money. Okay, you've got to wash with soap with a little bit of caustic in it at least, so you can get rid of the grease if you want to get rid of the grease. All right, otherwise you're wasting your money. So you wouldn't get a soap that's in this range.
Yeah.
Okay?
Yeah.
All right? So if you want to eat some tomatoes, definitely be around here somewhere. Okay? So that'll give you an idea of where pH is. And this is what pH means.
Yeah.
All right? So a lot of people talk about pH. It's on television, it's in advertisements, and mostly people actually don't know what it means. And this is what pH is. Okay? So what we'll do next time is we'll do some examples so that you can look at the concentration of a particular thing and then work out what the pH is. And there's one formula that I want you to know, okay? And that pH, okay, and that pH, the other way around, little p, pH is equal to minus log, the minus log to the base 10, yeah? Of the H plus concentration.
Okay.
All right. So if you do that, so if you plug into your calculator, for instance, this into your calculator, minus log of this number, you will get 7. All right. You'll get the number 7, obviously.
Yeah.
All right. So it's minus log of the hydrogen concentration. By the same token, the pOH, okay, the pOH is the minus log of the OH minus concentration, okay? But we're not hardly ever concerned with this. We really are concerned with the pH, so that's more described in terms of pH, and this is the formula for pH, okay? So next time we will do some examples of this, and we can do a chemical reaction, and then you can tell me what the final pH is going to be. You can predict it, what it is. There's also the other thing is we've got pKa and pKb to discuss. I'll discuss that with you later.